Hello folks, so today let's look at two important formula in coordinate geometry. One is called the distance formula and the other one is the midpoint formula, right? So in the previous video, we did talk about coordinate geometry as a branch of math that links algebra and geometry, right? And we looked at what a Cartesian plane is and how we can represent points as a pair of values, an ordered pair of values where the x coordinate comes first, followed by the y coordinate, okay? So yes, the story goes that René Descartes tried to, he looked at a fly on the ceiling and he wanted to devise a mechanism of letting anyone else know where exactly the fly could be on the ceiling. The story is could be as true as Newton and the Apple story, right? We don't know. Nonetheless, this is the Cartesian plane named after him, and it has 4 quadrants, and we mark points like this. We've covered all of this in the previous class. And coordinate geometry is also called as analytic geometry. The main thing here is that algebra is used to model geometric elements and algebraic notations, right? It could be inequalities to depict a region, equations to depict various shapes. It could be a line, it could be a circle, right? All these can be used to determine or to describe geometric objects. Fantastic. Okay. Now let's directly jump into the distance formula. What does this formula help us do? If we have any two random points, which is, let's say we have point A with coordinates x1 and y1 and point B with coordinates x2 and y2, then this formula will tell us what the distance between these 2 points could be. Now, bear in mind, the coordinates themselves can be positive or negative. We've looked at that in the previous slide out here. Based on which quadrant the point lies in, it can be positive or negative. But the distance is always positive, okay? You just have to remember that the distance is always positive. Cool, let's derive the formula. For that, let's consider the Cartesian plane. We have a line here, and let's say we have a point A and a point B out here. So let this be A, let this be B. The coordinates of A are, I know as per this diagram, the coordinates of A are 2 and 1, but because we want to derive a generic formula that could apply to any point, any set of points, let's call this x1, y1, and let B be x2, y2. Okay, guys. Now, the goal is to find this distance AB. So what we've done out here is we've drawn a line passing through B that is perpendicular to the x-axis, okay? And then we draw a line passing through A that is perpendicular to the y-axis, okay? And because x and y are in turn perpendicular to one another, you will observe that these two lines are also perpendicular to one another, okay? Or in other words, you could also say this line is parallel to x-axis, and the other line is parallel to y-axis. Let's call this point where these two lines meet as the point C, okay? Now, if you look at triangle ABC, it's a right angle triangle, right? Triangle ABC is a right triangle. So the hypotenuse, the square of the hypotenuse, that is AB square, right, is equal to the sum of the squares of the other two sides, AC squared plus BC squared. Okay, so let's try and find out if AB squared is this. AB is definitely going to be root of AC squared plus BC squared. Okay, so in order to substitute the value of AC and BC here, let's find out what AC is. Cool. So let's focus on the point C. The point C, the y coordinate of point C is actually the same as the y coordinate of point A. Can you see that? The y coordinate is always this distance, right? The perpendicular distance from the x-axis. Whether it is for point A or for point C, the y coordinate of both of these are the same. It is y1. Okay. What about the x coordinate of the point C? The x coordinate of point C is actually the x coordinate of point B. Why is that? Because the x coordinate is the perpendicular distance from the y-axis. So both point C and point B are at the same perpendicular distance from the y-axis. So comfortably, we could write this as x2. Right, guys? So let's just erase this quickly. Okay. So you got the coordinates of point C. Now what we're going to do is find out what this distance AC could be, because both A and C lie on the same line. This distance is nothing but x2 minus x1, right? Why is that? Observe here. This complete distance, guys, is x2, okay? And this complete distance out here, is x1. So x2 minus x1 will actually give you AC. This is given by x2 minus x1. I hope you got that. Similarly, if you look at the distance BC, it is y2 minus y1. Is it clear, folks? You apply the same thing here. B and C lie on the same line. So the vertical distance, so this completely is y2 for you. This is y1 for you. When you subtract them, you will get y2 minus y1 of BC. Let's just plug this back in the equation to find AB. Then AB is given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is the distance formula if you know the coordinates of any 2 points. It's very, very easy. It's very intuitive. It's x2 minus x1 the whole squared plus y2 minus y1 the whole squared. Do not put a plus or minus here, because we know that the distance is indeed positive. Okay, fantastic. Now just bear in mind that even though we derived this formula for 2 points in the first quadrant, you will end up with the same result even if you were to pick any other quadrant, right? If we had the same 2 points here, okay, and then you would drop the perpendicular and you draw this right angle triangle, when you apply the same thought process as we did in the previous diagram, you will still end up with x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, fantastic. Happy learning, guys.